Okay, guys, today in math, we're starting a new chapter and we're working with geometry a little bit more. We worked in that a few chapters ago, but we're going to just extend our knowledge of geometry into working with it in different ways. So I want you to get your math journals, and you should have a geometry page that talks about lines and rays and line segments, okay? I did not bring my math journal home, so I rewrote some of the things just to remind us. But if this is already in your math journal, you don't have to write it, okay? It's just kind of a review for us. Okay, so I'm going to show you in a second here. There we go. Okay, so check and see if this is in your math journal where we have a line, and we show a picture of a line that is it goes in both directions, on, and with no ending point, right? A ray has one end point, and then the rest of it goes on and on. So we talked about like the sun's rays, right? When they extend from the sun and keep going. So that's a ray. It has an end point, and the rest of it keeps going, okay? So a line segment is like we took a portion of a line and put endpoints on it, okay? So line segment has two endpoints. That's a line segment. So you should have these all in your journal already. If not, pause and you can get that going again, okay? All right, so another thing that we want to review is that when two rays come together, the endpoint that they share is called a vertex, okay? So remember in our geometry chapter before, we had to keep drawing the dots on the vertex, okay? So that's the vertex. When two rays come together and share an endpoint or share a vertex, they make a corner, and those corners are called angles. So that should all be review for you. Okay, so if you already have that in your journal, you can move on and get ready for the next thing. If you don't have this in your journal, you can pause and get caught up on that. Okay, so let's move on. So the thing that I want you to write for today's lesson are a few different terms. The first one we have is called polygons. Now, the root poly means many, many. So we use that with a lot of different words that you'll experience later in life. But poly, just think about it as meaning many, okay? So polygons are figures or shapes that have many sides and angles and no openings. So go ahead and write that down. Let me see if I can hold it still for you. Okay, so polygons means figures, and then another word for figures is shapes, so we put that in parentheses, that have many sides and angles and no openings. Polygons are figures or shapes that have many sides and angles and no openings. Okay, if you're not done with that, press pause so that you can catch up with that. And I'm going to move on. Okay, the next thing I want you to write is a term called plane figure. Okay, this is a geometry term that you'll want to remember. Okay, now notice this is not P-L-A-I-N, like the word that means ordinary. It's plane, P-L-A-N-E. And a plane figure just means it's a flat shape, okay? So it's not a shape like this that's three-dimensional, right? It's just a flat shape that you could draw on a piece of paper, okay? So plane figure, just keep in mind that that means flat shape. Okay, if you are not done, please push pause until you're ready. Okay, the next thing that we want to write is the word quadrilateral. How many syllables does that have? Quadrilateral. Okay, quadrilateral is a very fancy name for a four-sided plane figure. Okay, so it has four sides. Think about that. It's a flat shape because it's a plane figure. And there's many different kinds of quadrilaterals, okay? So like a square, a rectangle. This is called a parallelogram. A trapezoid, right? So all of these are quadrilaterals because they're four-sided and they're plain flat shapes. Okay, so I want you to get used to that word because a lot of times we'll use this word meaning to have meaning for any of these, but then when we want to talk about a specific kind of quadrilateral, then we'll mention square or rectangle, but you need to know quadrilateral. So this part of the word quad means four, and this part of the word lateral means side. So quadrilateral, four side. That's what it means, four-sided plane figure. Okay, so that's all you need to write in your journal today. So pause it until you're caught up, and then push play when you're ready to go on. Okay, so in your workbook on page 245, it would be a great thing for you to read this story about Haley and Amos and see how God has created shapes and put them in his own design in creation, but he also gives us shapes to use, and we can use them in lots of different ways. If you just stop and look at your house, I am looking at shapes all around me. I'm seeing squares and rectangles and triangles and all kinds of shapes all around me, and so you can too. All right, so I want you to look on page 246. We're just going to go through some of these together, okay? So page 246. So Amos described to Haley how he used geometrical plans the shapes to plan his painting. And we've done this too in art where we had to think of the shape of something, and we'll be doing that some more when we come back. Okay, so here is how Amos was describing. Okay, so let's look at the trees that he made. What shapes do you see? Okay, so hopefully you said there's a triangle right here, right? And a triangle right here. And then I see a rectangle right here, or a quadrilateral we could call it, right? And there's a quadrilateral right here with this rectangle. Okay, and then think about the house. Think about all the shapes that you see. Okay, so I see a triangle right here, right? I see a square down here. I see a rectangle and another small square. So all of these are quadrilaterals, right? But we also have, if you take this line away right here, we have a pentagon shape because it's 5 sides. 1, 2, 3, 4, 5. Okay, so that is a pentagon shape. So look around and see what kind of shapes that you can see. All right. Let's see here. Let's look at number 4 on page 246. It says, Amos told Haley that a quadrilateral is a plane figure with 4 straight sides. Isn't that what we just wrote in our journals, right? And soon she was noticing quadrilaterals all around her. What are some quadrilaterals Haley might see in her house? Okay, so I'm just looking around my house, and you see if you can compare. So I'm looking around my house. I'm looking in my kitchen, and all my cabinets are rectangle shaped. My big island is a huge rectangle. I'm seeing a square rug. I have little squares of glass in some of my cabinet doors. The seats on my stools at my island are squares. So what do you see? Okay, so think about all of those quadrilaterals. Okay, so let's move on. So remember, we talked about a line segment, which is a line with 2 endpoints, okay? On your workbook page, you're going to see that they have an example of using toothpicks and marshmallows. I don't have any marshmallows, but I do have some Sour Patch Kids that I cut up. Okay, so this is kind of representing a line segment, right? Now, this is not a plane figure yet. It's not a polygon yet because we only have one side. But we can take this line segment and make it into a closed figure or a closed shape by connecting line segments and having them share vertices. Remember, vertices is plural for the word vertex. Okay, so here's one line segment. I can create another line segment. And look at here. I can have them share this same endpoint, okay? And that's a vertex, and this is my angle right here. These line segments now, we're calling them sides, okay? So I can take another line segment and connect it, okay? All right, so now I have 3 line segments, right? So now that I've made a closed figure with no openings, I have a plane figure and I have a polygon, right? A polygon means a many-sided shape, and here I have 3 sides. So let's take a look at this. So how many sides do I have? 1, 2, 3. How many angles do I have? Well, I have this corner right here, I have this corner right here, and this corner right here, 3. And then how many vertices do I have? Well, here's a vertex right here, here's one here, and here's one here. So I have 3 sides, 3 angles, and 3 vertices, right? Okay, so I could add line segments, right? So I could take this apart, and I can add another side to it and connect it to my vertices. Okay, so now I have 4 sides. All right, so 1, 2, 3, 4 sides, right? And think about how many corners I have. How many angles do I have? Well, I have 4 of those too, right? Here's a corner, here's a corner, here's a corner, here's a corner. And then my Sour Patch Kid pieces are my vertices. That's where the line segments come together and share an endpoint. Okay, so this would be a quadrilateral because it has 4 sides. So think of this pattern. When we had the triangle, which tri, by the way, means 3, right? When we had the triangle, we had 3 sides, we had 3 angles, we had 3 vertices. Okay, so now I have a quadrilateral or a square. And how many sides do I have? How many vertices do I have? And how many angles do I have? So think of that pattern. I have 4 sides, 4 angles, 4 vertices. Okay, I could add another line segment to this. Okay, so then that would make 5, right? Because I just went from 4, and I can connect those in a moment here. Okay, so I can connect an additional, whoa, it's kind of falling apart. Okay, there we go. I can connect an additional line segment. Let me push my line segments into their vertices a little bit better. Okay. All right, so I added 1 more line segment. So count the sides now. So I have 1, 2, 3, 4, and 5, right? 5 line segments. And take a look at the vertices where the line segments join together. How many of those do I have? So you're counting the candy pieces. So I have 5 sides, 5 vertices. Now count the corners, the angles. So yes, I have 5. Are you guys seeing the pattern? So this 5-sided figure is called a pentagon, okay? And we could keep going. We could keep adding line segments. If I added 1 more, I'm going to have something called a hexagon. If I add 1 more, I would have 8, and that would be called an octagon. So you can see this. You can see this right here, okay? So what we're going to do on this page is you need to do a few things, all right? You need to put a dot on each vertex. Okay, so what would I put, where would I put the vertex or the vertices for my triangle? That's right, I would put one at each place where the line segments come together. Okay, so you're going to draw a dot, draw a dot, draw a dot. Okay, And those are my 3 vertices. Okay, so then I'm counting the sides. Here's a side. Remember, a line segment is a side. So here's 1, here's 2, here's 3. So we have 3 sides. And how many angles do we have? Remember, the angles are these corners, 1, 2, 3. And then our vertices are the parts where the sides come together, where the line segments share an endpoint. And so we have 3 of those. Okay, so you're going to do the same thing. You're going to put a dot where the vertices are, where the line segments come together. Okay, so in each place where the line segment comes together, you're drawing the endpoint for those, which makes the vertex. And then you're going to count the corners. All right, so how many sides do we have? We have 4. How many corners or angles do we have? We have 4. And how many vertices? We have 4. Okay, so I think you're getting the pattern just fine, right? Okay, so remember, a pentagon is a 5-sided figure. A hexagon is a 6-sided figure. And an octagon is an 8-sided figure. Okay, down here, if you had this number of marshmallows and this number of toothpicks, which shape could you make? All right, and if you have some toothpicks and marshmallows, ask your mom or dad if that would be okay for you to experiment, okay? All right, so that is what we have for today. We do have a little bit of division on the back side. Okay, so remember, this is division, not multiplication, so you have to think 24, let's see, let me go to this one. You have to think 60 divided by 6, so your answer goes here. So if you want to use a fact family, you can think what times 6 equals 60, and then you would put your answer here. Okay, please don't get rusty on your division and your multiplication. I hope you're still working on your facts. Okay, so if you forget the terms right here, if you forget what they mean, they are also on the front for you with their names of the figures. Okay? All right, so go ahead and finish that workbook page. And you may send a photo in. Okay? Thank you.